So today I'm going to be talking about intermolecular forces in relation to Coulomb's law. I know this topic may seem never-ending and impossible to know everything about IMFs, but I will try my best to inform you about the key details about IMFs. So this is Coulomb's law, and F stands for the force between the two molecules, the strength of the IMF, and then K is just a constant, and then Q1 and Q2 are the charges of the particles, while R is the distance. So Coulomb's law tells us that like charges repel, and so that would mean that opposites attract. So Coulomb's law tells us that the farther the molecules are from each other, then the weaker the IMF will be. So if you increase the distance, which is on the denominator, then that's going to make the force of attraction a smaller number. That being said, the closer the molecules are, the stronger the force. Moving on to the three major IMFs, we have the dipole-dipole interaction, hydrogen bonding, and dispersion forces. Dipole is the attraction between the positive end and the negative end of one molecule, and it forms when there's a large difference in electronegativity between the two atoms with a covalent. Dipole is between polar molecules, and this is because the electronegative atom pulls, or the more electronegative atom pulls the electrons towards itself, making it polar. And there's an example at the bottom showing that chlorine will have more electrons going towards it because it is the more electronegative. Okay, so if you can't read that, that says hydrogen bonding, and hydrogen bonding exists when you have an H attached to an F, O, or N. So an example would be water, because a hydrogen is attached to an oxygen. And so with the blend and dispersion forces, it's temporary and it applies to nonpolar molecules, and the electrons are in constant motion, so they can move around inside them. Hydrogen bonding is the strongest IMF, with dipole-dipole following, and then London dispersion being the weakest.
Phase diagram, and so this is a solid phase, a liquid phase, and the gas phase, and it goes up by pressure and then temperature on the x-axis. And this could show up on an FRQ or even multiple choice for the AP exam, and it's important to know that's with the different phase changes on the AP exam for this topic, and it just shows the phase changes this way, like the physical changes from solid to liquid to gas. Just showing an LDF attraction between these two molecules. The molecules' Lewis dot structures and the attractions between them. This is hydrogen bond, but yeah, you can be asked to draw something similar to this.
While taking the exam, it's important to keep in mind the phrase overcoming IMFs, because you can't say, for example, breaking a bond, because IMFs aren't bonds and they're just attractions. You could also say overcoming attractions when answering a question. You could also say Coulombic attractions whenever you are trying to explain why opposites attract and why a further distance between molecules decreases the strength of their force. The greater the number of electrons a molecule has, then the stronger the IMF or the attraction will be. You should also know a network covalent bond, and a network covalent bond usually occurs in silicon, boron, and diamond and graphite, which is carbon, and these bonds have stronger attractions than hydrogen bond. This ability describes how easy or how hard it is for the distortion of the electron cloud in nonpolar molecules. So ammonia and methane have similar molecular masses, but ammonia has a higher boiling point, and this is because ammonia has hydrogen bonding, and this creates a larger and stronger IMF than methane, because methane just has a London dispersion, and that's a weaker IMF than hydrogen bonding.
Ethane is a gas and hexane is a liquid. So ethane and hexane both experience London dispersion forces, but a hexane has a greater number of electrons than ethane. So having a greater number of electrons will make the IMF stronger, and stronger to make it a liquid. And then ethane, since it has fewer electrons, this IMF will be weaker and it won't condense. Electrons per atom, and that will cause it to have a very high melting point. And so chlorine is nonpolar molecules, and they only form the weaker London dispersion forces, makes it have a low melting point.
So magnesium oxide melts at a higher temperature than sodium fluoride, and both of these molecules are ionic compounds. So one of the things you can look at for this question is the charges of the atoms. So magnesium oxide has 2 plus and 2 minus, and sodium fluoride has 1 plus and 1 minus. So the molecule with a greater charge creates a stronger attraction between the molecules.